DevOps and CI-CD Part 12. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain Docker volumes. Here's a strong way to approach it. What are Docker volumes? Docker volumes are the preferred mechanism for persisting data generated and used by containers. Normally, when a container is deleted, all data stored in its writable layer is lost. Volumes allow data to survive container restarts, recreations, and upgrades. Why do we need volumes? Without a volume, container database data if the container is removed. Docker rm miscall container all data is lost. With a volume, container Docker volume persistent storage data remains even if the container is deleted. Create a volume. Docker volume create miscall data list volumes. Docker volume ls inspect volume. Docker volume inspect miscall data. Use a volume. Docker run d. Name mysql v miscall data, or var or lib or mysql miscall 8 here. Miscall data. Docker volume or var or lib or mysql container path. Database files are stored in the volume. Volume lifecycle. Create volume attached to container. Container stops. Container deleted. Volume still exists. Volumes are independent of container lifecycle. Types of Docker storage. 1. Volumes. Recommended. V myvolume, or data managed by Docker. Best performance. Easy backup and migration. 2. Bind mounts v or host or data maps a host directory directly into the container. Example, host, or app or logs container, or logs. 3. TMPFS mounts. TMPFS or data stored only in memory and removed when the container stops. Docker Compose example version 3.9 inches. Services, MySQL. The exact commands and code are in the written question bank. Nice, let's continue. Question 2. What are bind mounts? Here's a strong way to approach it. What are bind mounts? A bind mount maps a file or directory from the host machine directly into a container. This allows the container to access and modify files on the host file system. Example, host directory, or home or ack// or app container directory, or app run container. Docker run v or home or ack// or app nginx architecture. Host or home or ack// or app container or app. Any file changes on the host are immediately visible inside the container, and vice versa. Use cases. 1. Local development. Docker run v $pwd, or app node 20. Edit code on your laptop. Container sees changes instantly. No need to rebuild the image. 2. Configuration files. Docker run v or etc. or nginx conf, or etc. or nginx conf nginx. 3. Log sharing. Docker run v or var or log or myapp, or logs. Myapp logs are stored directly on the host. Read-only bind mount. Docker run v or host or config, or app or config. Row myapp row equals read-only. The container can read files but cannot modify them. Bind mount versus volume feature. Bind mount. Docker volume storage location. Host file system. Docker managed storage managed by host OS. Docker portability. Lower higher host path required. Yes no. Development use. Excellent good production use. Limited recommended. Advantages. Easy access to host files. Real-time synchronization. Great for development. Useful for configs and logs. Disadvantages. Depends on host directory structure. Less portable. Potential security risks. Harder to migrate across servers. Interview answer. 7+ years experience. Bind mounts are a Docker storage mechanism that maps a specific file or directory from the host machine into a container. Unlike Docker volumes, bind mounts are managed by the host file system and require an explicit host path. They are commonly used in development environments for source code sharing, configuration management, and log collection. While bind mounts offer flexibility and real-time synchronization, they reduce portability and are generally less suitable than Docker volumes for production persistent storage. Great, moving on. Question 3. Explain TMPFS mounts. Here's a strong way to approach it. What are TMPFS mounts? A TMPFS mount is a Docker storage mechanism that stores data only in the host's memory, RAM, instead of writing it to disk. The data exists only while the container is running and is automatically removed when the container stops. How TMPFS works. Container TMPFS mount. RAM no data is written to container writable layer. Docker volume host file system. Create a TMPFS mount. Docker run TMPFS or app or cache nginx or Docker run mount type equals TMPFS destination equals or app or cache nginx. Example, Docker run it TMPFS or temp Ubuntu inside the container. Echo hello. or temp or test.txt. The file exists while the container is running. After the container stops, test.txt deleted. Use cases 1. Sensitive data, passwords, tokens, temporary secrets. Since data is never written to disk, exposure risk is reduced. 2. Temporary cache application. Cache session data. Scratch files provides faster access because data is stored in RAM. 3. High-speed temporary storage applications requiring very fast temporary I/O can benefit from TMPFS. Set size limit. Docker run. Mount type equals TMPFS. Destination equals or temp. TMPFS size equals 100 MB. Ubuntu limits TMPFS storage to 100 MB. TMPFS versus volume versus bind mount feature. TMPFS volume bind mount stored in RAM disk host file system. Persistent. No. Yes. Performance. Fastest. Fast depends on disk. Survives restart. No. Yes. Suitable for secrets. Yes. No. Advantages. Check mark. Very fast I/O. Check mark. No. Disk writes. Check mark. Good for temporary data. Check mark. Better handling of sensitive temporary information. Disadvantages. Cross mark. Data lost when container stops. Cross mark. Consumes host memory. Cross mark. Not suitable for databases or persistent storage. Interview answer. 7+ years experience. TMPFS mounts are in-memory file systems used by Docker to store temporary container data directly in RAM instead of on disk. Data stored in a TMPFS mount is not persisted and is automatically removed when the container stops. TMPFS mounts are commonly used for temporary caches, session data, and sensitive information that should not be written to disk. They provide high-performance storage but consume host memory and are unsuitable for workloads requiring persistent data retention. Alright, next question. Question 4. What is container isolation? Here's a strong way to approach it. What is container isolation? Container isolation is the mechanism that separates containers from each other and from the host system, ensuring that processes, files, networks, and resources inside one container cannot directly interfere with others. Although containers share the same host OS kernel, they behave as if they are running in their own independent environments. Why is isolation important? Without isolation, container A can access container B's files or processes. With isolation, container A, container B, own file system, own processes, own network. Linux technologies behind container isolation. 1. Namespaces provide isolation. Types. Namespace isolates PID processes, NET networking, MNT file systems or mounts IPC interprocess communication, UTS host name and domain name, users and groups. Example. Inside a container, PSOX, the container only sees its own processes, not all host processes. 2. Groups. Control groups. Groups limit resource usage. Example. Docker run. Memory equals 512 M. Pus equals 1 GINX. Limits. Memory equals 512 MB. CPU equals 1 core. This prevents one container from consuming all host resources. 3. File system isolation. Each container gets its own file system view. Container A or app, container B or app changes inside one container do not affect another container's file system. 4. Network isolation. Each container gets its own IP address routing table. Network interfaces. Containers communicate only through configured networks. Security isolation. Additional security layers include Linux capabilities, Secomp profiles, AppArmor, SE Linux read-only file systems. These reduce privileges available to containers. Container versus VM isolation feature. Container VM isolation type: OS level, hardware level, kernel. Shared separate startup time, seconds, minutes, resource usage low, higher isolation strength. Good, stronger VMs generally provide stronger isolation because each VM has its own operating system kernel. Example: run 2 containers. Docker run D. Name app 1 GINX. Docker run D. Name app 2 GINX. Each container has its own process space, has its own file system, has its own network namespace, cannot directly access the other container. Interview answer. 7+ years experience. Container isolation is the mechanism that separates container workloads from each other and from the host system while sharing the same operating system kernel. It is primarily achieved through Linux namespaces, which isolate processes, networking, file systems, and users, and groups, which enforce resource limits on CPU, memory, and I/O. Additional security controls such as Secomp, AppArmor, SE Linux, and Linux capabilities further strengthen isolation. While containers provide lightweight and efficient isolation, virtual machines offer stronger isolation because they use separate operating system kernels. In modern cloud-native environments, container isolation is fundamental for multi-tenant security and workload stability. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.